Now, I've spent some time in these videos being pedantic about NP hardness, and let's do another one of those. Last time we briefly encountered a version of the sum of radicals problem, where it turned out comparing sums of square roots is tricky. But irrational numbers are kind of wild, right? So maybe that shouldn't really be a surprise. And surely it's a bit of a niche concern. Irrational numbers? Surprise! Geometry. Euclidean distance has square roots, so this is kind of a big deal, actually, and it bites both ways for NP completeness. I'll give two examples. I was working on some problem, and it had weights that realistically should come from Euclidean distances. With arbitrary integer weights, an NP hardness proof was fairly easy, but in order to get those weights from a set of points, I ended up giving some of them irrational coordinate values. So if you forget about having to write it on a Turing machine tape, the first proof works, but it doesn't, of course, because, repeat after me, NP hardness is about Turing machines. So I showed that you could round the coordinates to a particular precision, and all the properties I needed for the reduction to work were still true. And then, but only then, had I shown NP hardness. In addition to screwing up hardness proofs, irrational numbers can also mess with membership in NP. One way to think about NP is the existence of a polynomial size certificate that can be checked in polynomial time, and often that's how you would think about showing membership in NP. Now consider unit disk graphs, which are the intersection graphs of sets of unit disks in the plane. Their recognition or realizability problem is this. Given a combinatorial description of the graph G, is this actually a unit disk graph? That is, does there exist a set of unit disks whose intersection graph is G? That may sound like surely it's in NP, since we can certify it with, for example, the n centers of the disks. But wait, how are we going to encode this? How precise do we need to be with these points? It has been shown, actually, that there exist unit disk graphs where, if you're going to explicitly write the actual coordinates, you need exponential precision. So that's not actually a valid certificate for showing membership in NP. The precise situation is a little bit tricky, but you can look up the details if you need to. Or we could bite the bullet and say that we are fine with real numbers in the certificate, and then we get a complexity class called Existential Theory of the Reals. Existential in the sense of a quantification, like there exist real numbers such that so-and-so. And this unit disk graph recognition problem is actually complete for this class, but again, you can look up the details if you need them.